frozen wastes of Labrador in northern Canada, a team of scientists believe they're racing towards an extraordinary discovery. If they're right, global warming will have surprising and potentially disastrous consequences for Britain. Our climate won't be heating up, it'll be cooling down. In as little as 100 years, we could be swapping cars for skidoos. Welcome to The Big Chill. This remarkable story begins 30 years ago and 1,500 miles due east from Labrador with an unusual piece of detective work. This is St Bees on the northwest coast of England. We're at the same latitude as Labrador, but thanks to the Gulf Stream, it's a balmy 15 degrees warmer. In the 1960s, a lone scientist first came here and found hidden in these cliffs evidence that our benign climate could no longer be taken for granted. Armed with little more than a trowel and a spade, Russell Coop found a way to travel back in time to the end of the last ice age 13,000 years ago. The mud of these eroding cliffs revealed that the climate had been behaving in distinctly odd ways. The evidence came in an unlikely form.
This is a beetle called Pecilus. It's a ground beetle, a carnivorous beetle, that runs about in the sun. It's a brilliant green. And you can see the colour still preserved after 13,000 years, just as it was when the animal was alive.
To Russell's trained eye, every beetle tells a story about climate. Each variety was suited to a particular temperature. If the climate changed, one group beetled off and their cousins, who preferred the new climate, moved in. They're like prehistoric weathermen. Russell had chosen his spot well. He was digging in the remains of an ancient pond that had slowly filled up with mud and with beetles unlucky enough to fall in. As he excavated this beetle graveyard, Russell's inspired idea was to use the comings and goings of these sensitive creatures to piece together a picture of climate change. If accepted theories were true, Russell would have expected the lowest layers of mud, dating from the end of the Ice Age, to be full of cold-weather beetles. At the top, the more recent layers would be warmth-loving beetles. But when he analysed his findings, he came across something very puzzling.
When I got my samples back to the laboratory and started to find that the samples numbered from here had very warm beetles in them, and the samples from up here had cold beetles, I'd really got the samples upside down. And that I thought for quite a long time that I must have mislabeled the samples.
The startling story the beetle samples told was that the climate had got colder, not warmer. The beetles should have shown gradual changes over long periods of time, from cold to warm.
To my surprise, it didn't turn out like that classical picture. For the insects that lived at this time were warm indicators, indicating a climate at least as warm as southern England. Strange, isn't it? And then, all of a sudden, at this point here, all those southern species suddenly vanish from this sequence. And they're replaced here by a series of North British species, suggesting a very, very sudden climatic change.
To widespread incredulity, Russell suggested that the climate had changed in a series of abrupt steps, each one taking place within a single human lifetime.
So we have a stairway, really warm like southern England, then a sudden drop in temperature, then another sudden drop in temperature, then another sudden drop in temperature, and then another, as a series of stepwise drops. From here, warm as southern England, to here, as cold as Arctic Scandinavia.
Just when it should have been getting warmer, Russell argued that northern Europe had been plunged back into a mini ice age. It had lasted for more than 1,000 years and then, just as suddenly, ended. If he was right, if a sudden freeze had happened this quickly in the past, it could certainly happen again. But for years, nobody believed the man with the trowel and the beetles. Climate change at this speed simply wasn't possible. Russell Coop remained a lone voice in the Cumbrian wilderness. This was the accepted version of climate change when Richard Alley started out as a scientist. And it was all down to the sun. Small changes in the Earth's orbit seem to account for the climate's leisurely ebb and flow.
The prevailing view of climate change has been that the ice comes and the ice goes slowly. It happens because the Earth's orbit around the sun has interesting little features in it, little wobbles and changes in shape that change where and when we get sunshine on Earth. We still get the same amount of sunshine, but do we have long, hot summers in Europe, or do we have short, cool summers in Europe? And those change over tens of thousands of years. And a cold time would bring the ice, and then eventually it would warm, and then it would cool again 100,000 years later.
But Richard suspected the mud from the ocean floor wasn't telling the whole story. He knew it was laid down so slowly that each measurement covered hundreds of years at a time. Anything that happened more quickly than this would fail to register. It was these shorter periods that interested Richard. He needed to find evidence more detailed than the ocean mud. Evidence that would tell him directly what the temperature of the atmosphere had been in the past. It turned out the answer was literally falling from the sky.
Snow is one of the great materials for solving climate riddles. It's sampling the atmosphere as it comes down. The snowflakes grow around dust particles and they pick up pollen particles as they fall through the air. And the types of those tell us something about how cold or how warm it was, how windy it was, where the dust was coming. Other characteristics of the snow tell us really what the temperature was when it fell.
So Richard needed a place where the snow never melts. Snow has been piling up here untouched for hundreds of thousands of years. Each year's fall is compressed into ice and buried. At its deepest, it goes down more than 3 kilometers. For just 3 months each year, the climate on top of the ice cap eases to a mere 10 degrees below freezing, enough to allow people to live there. In 1989, Richard Alley joined a major project to drill through the ice. His goal was to reconstruct the climate of the last ice age in more detail than ever before. Year by year, season by season, it would reveal the secrets of climate change across the Northern Hemisphere. Richard shipped his precious frozen cargo back to its new home in Denver. Working with ice cores is no ordinary day at the office. Inside this freezer, at minus 34 degrees, is a bit of Greenland that will remain forever frozen. The ancient snow in these canisters, now compressed into thin layers of ice, has allowed Richard and his colleagues to do nothing less than rewrite the Earth's climate history.
When one looks at a piece of ice like this, the first thing we'd look for is the layering.
This is the extraordinary record that the Greenland ice core gave Richard for the last 100,000 years. Even during the Ice Age, the temperature repeatedly jumped up and down by 20 degrees or more every few thousand years.
At first, I didn't quite believe that these big climate jumps had happened. But the records of the ice cores and the records from many other places say that these big climate jumps did happen. The snowfall doubled in 3 years, and about 9/10 of that change was in a single year. The temperature change was sort of a decade or faster. Fast. This is not your lifetime. This is not even a single human generation. It's shorter than that.
In 1974, young oceanographer Wally Broecker had the pleasure of crossing the equator for the first time. He was traveling the world, studying the ocean's complex system of currents. Wally was an unusual scientist. He combined his passion for the oceans with a fascination for climate change. For years, he pursued the two interests separately. Then, at a seminar about the new ice core discoveries, a colleague said something that was to change his life.
He made the point that during the glacial time, it appeared that the climate system was leaping back and forth between two set states. I had never thought about that before, and I was very impressed. And I went home and I was trying to figure out what the two states could be.
Wally knew that the traditional theory, changes in the Earth's orbit around the Sun, certainly couldn't be responsible for these two climatic states. They simply didn't change fast enough. Then came his brainwave. Only his beloved oceans had the power to switch the climate so quickly. He knew already that the oceans have a huge influence on the Earth's climate. The Atlantic, for instance, soaks up heat in the tropics, creating a warm current that heads north and crosses the Atlantic. This is why Britain is so much warmer than Labrador. Wally's inspired new thought was that this warm current might be connected to a deep water current like an underwater conveyor belt. He called this system the Atlantic Conveyor.
Well, the Atlantic's conveyor transports an enormous amount of water. It's equal to all the rainfall in the world. So if you had two pipes, one transporting conveyor water and one transporting gutter pipe, taking all the rain in the world, they would have about equal amounts of water coming out. That means a conveyor is equal to something like 70 to 80 Amazon rivers.
Wally worked out that this mighty flow of water contributed about 30% of the entire heat received by Europe. It's equivalent to the heat from 1 million power stations. So if the conveyor's circulation were to go wrong, temperatures in Britain would suddenly plunge. Here was the vital breakthrough.
This was an important point in my career because I had spent 30 years up until that time studying, on one hand, ocean circulation, and on the other hand, paleoclimate. And the two didn't really overlap very much. And all of a sudden they came together because I realized that these two states could be the conveyor mode of circulation in the ocean on and the conveyor mode of circulation in the ocean off. And that hit me like a flash.
Wally's explanation for the big climate jumps was audaciously simple. Break the conveyor belt and the flow of warm tropical water to the North Atlantic would stop. Cooling would be sudden and extreme. But what was capable of switching off a force as immense as the conveyor? This was the easy bit. The answer had been around since Wally was exploring the ocean in the 1970s. This tank demonstration shows how the conveyor works. When salty conveyor water, coloured dark blue, is cooled by the Arctic winds, it gets denser and sinks. This sinking process is called convection. It's the mechanism that drives the conveyor. But if fresh water, here coloured light blue, floods the surface of the sea, then it dilutes the salt water so it's no longer dense enough to sink. Convection fails and the conveyor switches off. So the ocean, and with it the climate system, has two states, conveyor on and conveyor off. It was a revolutionary idea that at first found little favour.
My friend was so discouraged. He said, "Wally, we're just not getting anywhere with this." And I said, "Listen, we're right. The world will realize it, but it never happens so quickly. It's going to take 5 years for it to sink in. But I guarantee you we'll win in the end." And of course we did.
To test his unpopular theory, Wally had to find a moment in history when the conveyor had in fact been switched off. He looked back 13,000 years to the end of the Ice Age and the period that Russell Coop and his beetles had explored. By this time, the huge ice sheets which had covered much of Europe and North America for the previous 100,000 years were in full retreat. The conveyor was on. The climate was heating up. But it was now, Wally argued, that the conveyor was attacked by its greatest enemy. At precisely this time, a huge melting ice sheet was creating a gigantic lake across what is now North America. As the ice retreated, the lake suddenly forced its way east, releasing vast quantities of deadly fresh water. The result was a catastrophic flood.
Huge volume of water went whooshing down the St. Lawrence Valley into the Atlantic, right in the region where the densification and production of deep water occurs today. And the idea is that, boom, that killed the conveyor. And it took the conveyor then about 1,200 years until it could pop back on again.
It was a beautifully elegant theory. As the lake burst into the Atlantic, it flooded the conveyor with fresh water, suddenly stopping the water from sinking. The conveyor switched off. The North Atlantic region plunged back into its 1,200-year big freeze. One set of beetles moved on, another set moved in. Now Wally turned to the Ice Age itself, and the big climate jumps revealed in Richard Alley's ice cores. What regular source of fresh water could have repeatedly switched the conveyor off? Once again, the culprit was melting ice. He argued that periodically, huge armadas of icebergs sailed into the Atlantic. As they melted, they too flooded the ocean with fresh water, killing the conveyor. Only when the fresh water was gradually diluted over several thousand years would the ocean current be salty enough to start sinking again and switch the conveyor back on. Here, at last, was a convincing explanation of sudden climate leaps.
We're fortunate that a beautiful hypothesis was out there, and this is Wally Broecker's global conveyor shutdown. And it's very clear to me that what a global conveyor shutdown predicts is what we see in the ice core.
Suddenly, Wally Broecker was one of America's most celebrated scientists.
Well, as I look at my career, I've won awards and things, but those are not the things that really make it all worthwhile. What makes it worthwhile is when you beat nature. In other words, you force nature to reveal one of its secrets to you, and that doesn't happen too often.
Wally Broecker's conveyor theory explained how the Earth's climate behaved thousands of years ago. This team of scientists, led by American climatologist Jonathan Overpeck, is trying to discover whether the conveyor has been active in much more recent times. They've come to Labrador in northern Canada in search of evidence hidden beneath this frozen landscape.
I think Wally Broecker's idea of the ocean conveyor and how it affects climate is a really important and intriguing one. I think what he's doing in a sense is throwing down a gauntlet for us to look at the climate of the last 1,000 years to see if the conveyor has affected climate in dramatic ways.
The Atlantic conveyor has been on for the past 10,000 years. That's why Britain is warm, while here in Labrador, even in late March, it's still 10 degrees below freezing. But Jonathan's team believe the evidence they find here will reveal just how close the conveyor has recently come to that fateful switch off. They're heading for a small lake a couple of hours away by Skidoo, across the frozen sea. For the last few years, Jonathan has been visiting countries bordering the Atlantic to gather together pieces of a great climatic jigsaw puzzle. Putting the pieces together, he hopes to identify patterns in the conveyor's behavior. And here, in the far North Atlantic, where the conveyor is at its most vulnerable, he hopes to find the most revealing piece of the puzzle. The team set up camp by the edge of the frozen lake. It may be cold, but the metre-thick ice means they've got a perfect working platform. Their target is 5 metres below their feet. Mud at the bottom of the lake, which holds the secrets of the past climate for this whole region. Once the drill penetrates the ice, the lake water shoots up to its normal level. Each year, melting snow washes a fresh layer of mud into the lake, where it collects on the bottom. Just like the ice cores, these layers give a detailed record of the climate, year by year. To collect a column of this mud, Jonathan is using a technique called freeze coring. Dry ice will freeze the sediments to the outside of the aluminium box, preserving the layers in the mud.
This dry ice slurry that we're putting into the core is about minus 90 degrees C, and that's going to make the entire aluminum box of the core minus 90 degrees C.
If this technique works, the mud that emerges frozen to the outside of the box should shed new light on the Atlantic conveyor.
Okay. Thank you. Here we go. Frosting over already. We're going to send this one in pretty good. Okay. Well, the core is now down. You can see the CO2 gas bubbling off of the core, and that means the sediment is freezing to the outside of the core as we speak. And we'll leave the core in for about 30 minutes, and that'll allow the sediment to freeze about 1 or 2 centimeters out and give us a nice intact record of the sediments just as they were lying on the bottom of the lake.
What these cores reveal will answer a crucial question. Do sudden climate jumps belong only to the ice ages, or have they been happening much more recently?
We have a preliminary view of climate over the last several thousand years. And it's one that says that the climate of the last 1,000 years is not stable, but is one that's characterized by a lot of change, in particular in temperature. And we think that's tied in with changes in the ocean circulation, changes in the Great Conveyor.
Some of the best evidence of erratic behaviour from the conveyor comes from Europe during what's known as the Little Ice Age. Starting in the 14th century, the Little Ice Age lasted for about 500 years, with temperatures on average a full degree colder than today. That may not sound like much, but the effects were dramatic. In Britain, the Thames froze so solidly that winter fairs were held on it. At the end of the 16th century, the Little Ice Age was at its most severe. There was a sudden deterioration in the climate. In the Alps, glaciers suddenly surged forwards. In Grindelwald in Switzerland, this glacier had been barely visible from the village for hundreds of years. But in 1580, it broke loose. In just a few years, it advanced a kilometre into the main valley, crushing everything in its path. In some places, whole villages were swept away. Throughout Europe, crops failed. In the countryside, peasants began to starve. A Swiss chronicler, Johann Jakob Wick, sketched the terrible conditions in his journal. Children fell victim to hungry wolves. People searched for scapegoats. It was thought witches were to blame. They were accused of conspiring with the devil to change the climate. In many areas, suspected witches were burned by the 100. Victims of climate change.
Ooh, we even brought back some spruce. Oh, we got about 60 centimeters of mud here, looks like, from the bottom of the lake. And you can see the interface between the water at the bottom of the lake and the top of the sediments. That looks pretty good. And then as we go down here, where Alex has been scraping, you can see some really nice layers, laminations.
Under closer analysis back in Jonathan's lab, the frozen core's tiny slices, each representing a year's worth of sediment, will show how North America's climate developed over the last few centuries. Combined with minute fossil remains, they will allow a detailed record to be compiled.
Okie dokie.
Early results suggest that while Europe froze, a different climate disaster hit North America.
You want to do the pouring? The end of the 16th century is a very interesting time in North America. There was a major drought that started around 1580 and lasted 10 years in some areas and even longer, up to 20 years in parts of the United States. And that drought is coincident with a major climate anomaly in Europe. And Because of the proximity of both Europe and North America to the Atlantic, we're now starting to think it probably had something to do with a change in ocean circulation in the North Atlantic, perhaps a change in the conveyor.
Jonathan's core samples from around the Atlantic are beginning to show how vulnerable the conveyor may be. Some scientists argue it may even have come close to switching off during the Little Ice Age. We may just have had a very lucky escape. But will our luck hold? We could be in danger now more than ever before of shutting down the Atlantic conveyor and prompting another big freeze. At first sight, it seems our good luck could be continuing. The planet is getting hotter. Global warming is likely to heat up the Earth by another 2 or 3 degrees in the next 100 years. As we pump greenhouse gases such as carbon dioxide into the atmosphere, more and more of the sun's heat is trapped on Earth. But it isn't only going to be warmer. In parts of the world, it's going to be wetter too. As our weather systems change, much more rain will fall, flooding the North Atlantic with huge quantities of fresh water, the conveyor's greatest enemy. And if it rains more in the crucial areas where the conveyor sinks, we could force the ocean to do what nature has spared us for 10,000 years, shut the conveyor down. Jeff Jenkins is head of Britain's main centre for climate prediction. Jeff's team will analyse the clouds they're flying through in minute detail. The key question he wants to answer is, are clouds like these going to dump more rain in the North Atlantic?
The conveyor belt, so by looking at the uncertainties in cloud formation and cloud processes, we can actually say something about the extent to which the freshwater input to the North Atlantic could change the conveyor belt ocean circulation.
Small changes in the size and composition of water particles can dramatically change the amount of rainfall that a cloud produces. It's these changes that Jeff's highly sensitive instruments reveal.
We fly through the clouds, we see whether they're made up of water droplets or ice crystals, and the mixture we're getting at the moment through this cloud. See there, that red disk there represents a cloud droplet. There's another very big one, cloud droplet, as we're passing through it. And we see a collection of droplets. We see sometimes ice crystals. Here's one here, for example, of different shapes and sizes. And by counting these, we can understand more about how the cloud is made up and how it can be represented in the climate model.
Yeah, some of it.
Global warming will evaporate more water from the sea, so there's little doubt rainfall in the North Atlantic will increase. But scientists don't agree on the crucial question. Will the rain unleash enough fresh water to overwhelm the conveyor?
There are good reasons for believing that the conveyor belt ocean circulation has got points on it where things could change very dramatically, very quickly. What we find in our climate model when we run it forward 100 years or so is that we don't actually reach one of these points. But nonetheless, there could be uncertainties in the way we represent both the oceans and the atmosphere. That means that we may be closer to that point than we think.
In Germany, Stefan Ramsdorff fears that we may indeed be getting close to provoking a conveyor shutdown. He's spent his career building computer models to predict how much fresh water the conveyor can cope with before it shuts down. He's focusing on the key sinking or convection mechanism in the North Atlantic.
The convection process that drives the conveyor is actually quite fragile. It has been called the Achilles heel of the conveyor belt because it can be shut down if a certain amount of fresh water enters the region where this happens, or if the surface waters get heated, for example by global warming.
Stefan has repeatedly drawn attention to the vulnerability of this key process. And according to his model, there is a crucial point at which increasing fresh water could trigger a disaster.
The interesting thing about the conveyor circulation in the Atlantic is that it has a definite threshold below which it cannot drop. If it goes below that threshold, it then collapses completely. And we don't know exactly where that threshold is, but it's round about at half the current strength of the conveyor circulation. So if you push it beyond that limit, it will collapse.
Jeff Jenkins isn't so sure. He agrees that there is a threshold, and his model shows the conveyor does start to decline as global warming takes hold, but not enough to ruin our benign European climate.
When we run our models out the next 100 years with the best guess scenario for changes in greenhouse gases, we see the conveyor belt decrease by something like 20 or 25%. So that means there will be less heat input from the Gulf Stream into Northwest Europe. But on the other hand, there will be a terrific global warming during that time. And so the global warming will definitely win out, and we'll see Europe becoming warmer rather than colder.
Not so, says Stefan. Back in Potsdam, his model suggests a far more dramatic outcome.
We can see what happens in the model simulation here on the computer screen with the reddish and yellow colors indicating a warming. Here you can see Great Britain and the Atlantic where the Gulf Stream normally runs. When we start the simulation, there is a widespread global warming developing, and it's particularly enhanced in the high northern latitudes.
The trouble is, these abnormally high temperatures could have a disastrous effect. The Greenland ice could start to melt. Now it's not just increased rainfall, but a vast expanse of fresh meltwater that threatens to swamp the conveyor, with far-reaching effects. Stefan's model is about to turn global warming into Britain's big chill.
Now, if we run this for longer, further into the future, then in some scenarios the Gulf Stream extension here collapses and this very cold blue patch develops over the Atlantic. In fact, there are reasons to believe that the pattern will be shifted further over towards Europe, so that Great Britain could cool by 5 degrees or even more.
This, then, is one possible outcome of global warming. After an initial warm-up, the fragile mechanism that sustains our climate suddenly fails. The Atlantic Ocean turns on us. Drowned in fresh water, its conveyor shuts down. The Gulf Stream ceases to protect us from our exposed northern latitude. Temperatures in Britain plunge. Roads are blocked for months every year. Our winter landscape turns into an Arctic tundra. Farming collapses. Unlikely? Perhaps. But could it happen? yes. Many leading scientists now agree, unless we learn from the past, we're gambling with our future.
So what we see perhaps in the crystal ball of the future is that we're changing this climate in a predictable way in terms of what we're doing to the climate system, but the response of the climate system might not be that predictable. Instead of getting a gradual change, we might get an abrupt change. And I think the great conveyor, the ocean conveyor, is one mechanism where we might cross a threshold and get a jump from one climate state or mode of variability into another. And unless we can learn how to predict that, what we're doing, marching into the future, is risky.
You might say that mankind as a whole is making a supreme effort to knock out the conveyor, because by adding CO2 to the atmosphere, we're doing the most powerful thing we could do to affect climate. And it is going to warm up the polar regions and put more rainwater and snow onto the polar regions, and those are exactly the things that threaten the conveyor.
Will the climate change? Yes. I would be flabbergasted if the climate ever stayed stable for long periods of time. Are we likely to see bigger changes in the future than the ones we're used to? Quite probably. The climate has not been as boring as what we've had recently through most of history. And are there somewhere out there threshold switches that could be triggered that would cause dramatic changes? Yes. Where are those switches? Probably in the North Atlantic, maybe somewhere else, but in the North Atlantic. Are we about to throw one? I have no idea.